In this lesson, we will factor trinomials with the GCF completely. Factoring completely. In this example, we're asked to factor the trinomial completely. So we want to take out the GCF if there's any. So the first thing you should do if you want to identify whether there's a GCF among terms is to look at the smallest term. So in this case, the smallest term is a 6, and you ask yourself, is there a 6 inside 8? And the answer is no. So as soon as you get a no from any of the terms, then you know they don't have that number as their GCF. So let's look deeper inside 6. So inside 6, 2 times 3 is 6. So again, inside 6 is 2 times 3. So I already know that there is no 3 inside of 8. So the 3 cannot be the GCF because it's not inside 8. But let's try the 2 that's inside of the 6. So yes, there's a 2 in 6. Is there a 2 in 8? Yes, there's a 2 in 8. Is there a 2 in 30? And yes, there's a 2 in 30. So then 2 is our GCF. It is the number that they all share in common. Next, I want to find the GCF of the variables if there's any. Do they all share a y in common? And the answer is yes. At most, how many y's do they all share in common? So we can see here that at most they all share at least one y in common. So then our GCF then is 2y. So GCF on the outside, and the remaining terms that are left goes in parentheses. So when you're left with a second degree term of degree 2, degree 1, and a constant, a number, you want to try and see if you can factor it further. So we can probably factor this using one of those 5 methods we learned from the previous section. So I'm going to go ahead and factor it using trial and error. Now I know that if the back end is a negative, the signs are different, and that ways in which I can get 15, I will probably try the 3 and the 5 first before trying 1 and 15, and then just go ahead and factor it. And so when I factor it, what it factors into is 2y on GCF on the outside, but the trinomial itself factored into 3y plus 5 and then y minus 3. Now I want you to note that the whole concept I told you of when you have factoring, that the middle term will tell you the sign of the larger number. Well, whenever the coefficient is some number other than 1, this tells you the larger number of outer and inner, not the larger number of your pairs. Because note here, 5 is our larger number and it's negatives. So that rule doesn't apply there. When the coefficient is some number other than 1, this larger number refers to outer and inner, and here's what I mean. So if I multiply outer, 3y times negative 3 is going to give me negative 9y. And then inner is 5y. And notice here that my larger number is negative 9, and it is negative. And my smaller number is positive. So the middle term, when the coefficient is some number other than 1, refers to your outer and inner terms, the signs of your outer and inner. Because notice outer and inner did give me my middle term of negative 4. So that is the correct form of factoring it. 2y on the outside, your GCF, which has to be a part of your answer, followed by 3y plus 5 times y minus 3. In this next example, we're asked again to factor completely a trinomial. So again, we want to see if there's a GCF in terms of the number. The smallest number is 9. So we ask ourselves, is there a 9 inside 12? And the answer is no. So there's no need of looking inside 24 because, again, they all don't share that 9 in common. So we have to look deeper inside that 9 and see 3 times 3 is 9. So let's check and see if there's a 3 they all share. Is there a 3 in 12? Yes. Is there a 3 in 24? Yes. And we already know there's a 3 in 9. So therefore, the GCF in terms of a number is 3. Do they all share a y in common? The answer is no, they don't. So y cannot be a part of the GCF. Our GCF is just simply 3, so GCF on the outside, and the remaining terms in parentheses. When you are left with a degree of 2, a degree of 1, and a constant number, that is probably a hint that you can further factor that further. So let's utilize one of those 5 methods we've learned in a previous section and factor this trinomial. So notice if the back end is a positive, the signs are the same. What type of signs? 2 positives. The only way you're going to get 3 is 1 times 3. So my pairs are going to be with 1 and 3. And I'm also going to split up the first term. So I'm going to factor that. And when we factor that, we can check here our outer and inner and see if it equals our middle term of 8y. So outer 2y times 3 equals 6y. 1 times 2y is 2y. So 6y plus 2y, it does equal 8y. Checking your first terms, 2y and 2y does give me 4y squared, and obviously your last terms, 1 times 3, does give me 3. So it does check out. This is how you would factor this particular trinomial. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.